Okay, welcome to the last part of the trigonometry unit in Math 20-1. I'm going to go over the cosine law. The cosine law looks tricky, but it's really not that bad. So when we use a sine law with triangles, when we know an angle and a side opposite the angle are known, and they give us one complete ratio in the formula. Over here, we know, oh, excuse me, we know the angle B, and we know side length B here, so that's known. We're quite happy about that. We don't know sine length C, but we don't know angle C. Because of that, the sine law works. However, sometimes this isn't the case. Okay? Sometimes we don't get all this information, so we're gonna have to use something called the cosine law. The cosine law is this formula right here. We have two variations of it, or you can change it around to however you need. Now, for the cosine law, the triangle has to be labeled the exact same as before, just like in the sine law. And if we look, the cosine law, so if A, B, C are the sides of a triangle and C is the angle opposite, the cosine law is, okay? So there's a lot of alternate forms. All this is basically moving around the different letters and variation on each of those, okay? These are all in your formula sheet, so don't worry too much about memorizing it. How do we use a cosine law? It's actually quite easy. Check this, it says near centimeter, so we don't have to worry about any sort of exact measurement. And you figure out what information do I have? Well, I have a side length, I have another side length, I have an angle. I'm going to go ahead and label all these. Let's say this is angle C. That means this is side length C. Let's say this is angle A, and this is my side length A. Therefore, this is angle B. This is side length B. Okay. Well, what information do I have? I have a small c is unknown. I know that my big C is 17 degrees. I know my small a is 9 centimeters. And my small b is 14 centimeters. I'm going to go ahead, look at my formula sheet, and see, well, okay, I'm solving for small c. So I have small c, and I do have the angle c, and I do have a and b side length. So therefore, I can just use this. What that ends up looking like is I go c squared is equal to a squared plus b squared minus 2ab cosine c, and I just fill this all in. Okay, so I have a, which is 9 squared, plus b, which is 14 squared, minus 2 times 9 times 14, and I'm timesing that with cosine 17 degrees. Okay, this gives me a value of 36.011, and it carries on. I'm going to go on my calculator. I'm going to square root both sides. So on your calculator, you would probably do something like this, square root the answer, and that leaves us with 6.000, and it carries on for bits, so centimeters. So that means our nearest approximation is C is roughly equal to 6 centimeters. There we go. It's actually quite easy to do as long as it's labeled correctly. Let's do another one. Find angle theta to the nearest 10th degree. Okay, I'm going to go ahead and label everything. Again, you can label it however you want, whatever information you have, okay? Uh, Sometimes it's easier to look at your formula and label it based on that. So I don't have angle A, uh, but if I look at my formula, it says we're using cosine angle A is equal to BC A to BC. That means I'm just going to go ahead and label this A. Okay, therefore this is A. The next ones don't really matter because they're both side lengths, so I can just do BC. I could do it the other way as well. Okay, now in this case, all we do again is fill out that formula. So cosine A is equal to b squared plus c squared minus a squared over 2bc. That means this is going to be equal to 90 squared plus 102 squared minus 132 squared over 2 times b, so 90 times c, 102. This gives us 0.058, and that's what cosine A is equal to. How do we figure out the angle A? Well, you just do the inverse cosine. So A is equal to cosine, inverse cosine of 0.058, or you just toss in your answer here on your calculator. And our final answer is A should be roughly equal to 86.6 degrees. Okay. Now, remember, when we have cosine A is equal to 0.058, that's not our answer. That's not an degree that is quite measurable or what it should look like. Make sure that you are doing the inverse cosine to find the angle here. Last question. So we're solving the given triangle. Again, it means when it says solve like this, you need to find all the missing measurements. Okay. In this case, we need to solve this out. Okay. I'm going to go ahead and I'm going to look at my formula, but um, I'm going to show you what it is like if, let's say, I didn't use the formula like this. Okay. So I just did whatever for the formula. So I'm going to go ahead and I'm going to label this. Let's do red. I'm going to label this angle A, angle C, angle B, A, C, B, just like that. And information that we know is we know B, we know C, and we know A. Okay. This means I'm going to go over to my formula and I have to rewrite this. I have to be doing something that I know. So I'm going to go over and well, I'm looking for C. I know B and A. So that means it's minus 2BA cosine C. Okay, there we go. We just rewrote this formula to do whatever we needed to do. So if I go ahead and I were to write this all, so C squared equals B squared plus A squared minus 2BA cosine angle C. Whew, this is going to be a lot of substitution, so I'm just going to go straight over to the answer. So I get C is equal to 131.319 meters. Okay, so now that I know what C is, I know what C is 131.319 meters. I have a lot more information to work off here. I could keep going with the cosine law and keep finding this, but this is a lot of work in math. What else can I do? Well, all I need to do is find one more angle, and then I can solve the other angle using Pythagorean. Not Pythagorean, using the addition of angles. Okay. How do I do that? Well, the easiest way to do it is just using our sine law. Okay, so if I go ahead and use my sine law, I have A over sine A is equal to C over sine C. I'm going to go ahead and fill this out just for here. So I have 200 over sine A is equal to 131.1 point 319 over sine 40. Once I solve for this, I should get sine A is equal to 0.978. Are we done? Not quite yet. We're just have to solve for A. So A is going to equal to inverse sine 0. Ooh, 0.978, which gives us a degree of about 78.228 degrees, which means our angle A is 78. Yeah, let's 78 about. Okay. Our last step is just finding out what our angle B is. How do we do that? Well, again, you could use sine law if you really wanted the easiest way is just to do, well, angle B is just going to be 180, and it's going to be minus that 40 degrees, and it's going to be minus that 78.228 degrees, which gives us 61.771 degrees. If we put this all together now, or I'll round this again. So angle B is roughly equal to 62 degrees. If we round this up, all up, and put our answers all together, well, we know that C is about equal to 131 meters. We know that angle A is about equal to 78 degrees. And lastly, angle B is about equal to 62 degrees. And we have now officially solved our whole triangle. All right. Hopefully that's pretty good, and good luck on the rest of the unit.